and thank you for joining us for today's webinar, A Beginner's Guide to Flame Detection. My name is Brenton Harris. I've previously presented webinars that have focused on Protectowire products. However, today we're going to focus on flame detection, and joining me today is Ty Allen. Ty is the Inside Sales and Technical Support Manager for Spectrex Rosemont Flame and Gas Detection. With over 5 years experience in flame and gas detection, Ty has been trained on the Spectrex Flame and Gas products at Spectronics in Israel, where they were first developed, as well as trained and performed training in their Minnesota factory, where the Spectrex and Rosemont products are manufactured. Ty is a knowledgeable expert in the field with experience in assisting application selection and on-site troubleshooting. When not giving presentations, Ty works with distributors and end users to provide product information and troubleshooting support. In his spare time, he enjoys spending time with his daughter, visiting different new breweries, and traveling. He's based out of Houston, Texas. A few housekeeping items before we get started. As per usual, a link to this webinar will be emailed to everyone who's registered after the conclusion of the webinar. We also will have a live question and answer chat bar in the bottom left portion of your screen. Any additional or more complicated questions, feel free to forward those on to info, that's INFO, at protectowire.com. And with that, I'll let Ty begin.
Hello, everyone. My name is Ty Allen. I'm here to discuss Spectrex Flame Detection. We will go over the purpose of flame detection, technology selection, Spectrex Flame Detection portfolio, installation considerations, flame detection maintenance, and flame detection accessories. For a quick overview of Spectrex, we were founded in 1975 for automatic fire extinguishing systems for armored vehicles. In the 1990s, we developed the Sharp-Eye flame detectors, which is optical flame detection using UVIR, UV, and IR3 technology. In 1994, we developed the open path gas detectors using line of sight infrared wavelengths to detect gas in perimeter applications. Over the years, we have sold more than 30,000 vehicle systems and more than 100,000 industrial flame detectors through the life of the company. Our manufacturing capabilities are located in Shakopee, Minnesota. We are part of Emerson Rosemont, and we cover flame and gas detection, pressure, temperature, wireless, as well as a few other products in different areas. Our manufacturing site is 500,000 square feet and is a state-of-the-art lab and R&D facility. So again, our agenda will be the purpose of flame detection, technology selection, Spectrex flame detection portfolio, installation considerations, flame detection maintenance, and accessories. So the first one, purpose of flame detection. The range of potential flammable hazards is expansive and growing as materials and processes become more complex. Increasingly, sophisticated flame sensing technologies with embedded intelligence are required to detect the most common industrial fuels. Most flame detectors identify flames by so-called optical methods like ultraviolet and infrared spectroscopy and visual flame imaging. Flames in a refinery, for example, are generally fueled by hydrocarbons, which when supplied with oxygen and ignition source produce heat, carbon dioxide, and other products of combustion. Common industrial fuels such as diesel, gasoline, jet fuels, hydrogen, ethylene are some of the most common types of fuels that we encounter and we detect for. The purpose of flame detection. The primary objective is to detect fires as early as practical to minimize immediate consequences and prevent escalation. We want to isolate fuel sources, minimize the fire size and risk to personnel, environment, and damage to facilities. Our secondary objective is to achieve detection with minimum unwanted alarms and minimum installed and operation costs. Industrial applications pose challenging environments for fire protection systems. Flame detection is used to provide fast response to growing fires. Now, the chemistry of a fire. You start with an ignition source with fuel, and you add oxygen to it, and it causes a fire. So before we begin, the fire starts when a flammable or combustible material in combination with a sufficient quantity of oxidizer is exposed to a source of heat and is able to sustain a rate of rapid oxidation. That produces a chain reaction. This is commonly called the fire tetrahedron. Fire cannot exist without all of these elements in place and in the right proportions. Once ignited, a chain reaction must take place whereby fires can sustain their own heat by further release of heat energy in the process of combustion. Fires may then propagate provided there is a continuous supply of an oxidizer and fuel. Optical flame detection is based on detecting the unique characteristics of electromagnetic energy emitted by a fire. The characteristics that help differentiate a flame from non-flame background radiation include a spectral signature and frequency pattern. Flames emit electromagnetic radiation in a wide range of wavelengths. The precise wavelengths vary from flame to flame, depending on the fuel being burned, the oxygen supplied to the flames, and environmental conditions that affect the radiation transmission in the atmosphere. Many combustible materials include carbon. Combustion of such fuels typically generate hot carbon dioxide, which has a characteristic infrared emission spectrum with a relatively strong and well-defined peak at wavelengths around 4.3 microns, and relatively little intensity at wavelengths immediately on either side of the peak. Other combustibles such as hydrogen, ammonia, metal oxides, silane, and other non-organic fuels lack carbon, and therefore in their combustion process they generate hot water vapor. This hot water vapor has a characteristic infrared emission spectrum with a relatively strong peak around 2.7 microns. Most flame detectors identify flames by so-called optical methods like ultraviolet and infrared spectroscopy and visual flame imaging. Flames in a refinery, for example, are generally fueled by hydrocarbons, which when supplied with oxygen and ignition source produce heat, carbon dioxide, and other products of combustion. The intense reaction is characterized by the emission of visible UV and IR radiation. Flame detectors are designed to detect the absorption of the light at a specific wavelength, allowing them to discriminate between flames and false alarm sources. The general attributes of optical sensors. They sense radiant energy from an open flame, enabling rapid response to fires. Various sensor technologies used to detect all types of flame, capable of rejecting nuisance alarms caused by tough industrial environments, and have self-checking capabilities to ensure optical integrity. Technology selection. When evaluating the various flame detection technology alternatives available today, it is useful to consider the following flame detector performance criteria. First, false alarm immunity. False alarm rejection is one of the most important considerations for the selection of flame detectors. False alarms are more than a nuisance. They are both a productivity and cost issue. Furthermore, they can compromise the trust in the very system that is protecting. It is therefore essential that flame detectors discriminate between actual flames and radiation from sunlight, lightning, arc welding, hot objects, and other non-flame sources. Second, response time. A flame detector's most basic performance criteria is response time. Depending on a specific plant application environment, each of the alternative flame detection technologies recognize a flame within a distribution of response times. As you'd expect, early warning against fires and detonations is critical. Lastly, detection coverage. Detection range and field of view define area coverage per device. Like a wide-angle lens, a flame detector with a large field of view can take in a broader scene, which may help reduce the number of flame detectors required for certain installations. Most of today's flame detector models offer field of view of about 90 degrees to 120 degrees. Global array of third-party approval agencies have verified and documented false alarm rejection, response time, and detection coverage. Defining the requirements for an application is also essential. Factors such as the type of fuel, minimum fire size to be detected, and the environment and the configuration of the space to be monitored can influence the technology selection. We'll begin by discussing the fuel hazard. Flames emit electromagnetic radiation at a wide range of wavelengths. which vary depending on the fuel being burned. Both the residual hot gases and the intensity of the fire differ based on the fuel type. Therefore, fuel hazards must be taken into account when selecting optical technologies. Secondly, fire size. Since both sensitivity and range are related to fire size, if the detector is placed further away from the fire source, the detectable fire size will vary according to the inverse square law, meaning doubling the detection distance results in only 25% of the radiant energy reaching the detector, or conversely, for the same response time, the surface area of the fire then needs to be 4 times larger. Lastly, flame detection sensitivity is subject to degradation based on false alarm stimuli and atmospheric conditions. Selecting the right flame technology. So a couple aspects to consider are the characteristics. What is the size of the fire that you'll be monitoring? What is the detection distance? And what is the response speed? You need to consider the fuel type. Is it a hydrocarbon-based or non-organic? Is it a liquid, gaseous, or solid? And then you need to consider the false alarms. Are there radiation sources? Are there environmental factors? Is there oil present, grease, weather extremes, etc.? The different optical flame sensing technologies are ultraviolet, infrared, multispectrum infrared, and visual flame imaging. UV detectors respond to radiation in the spectral range of approximately 180 to 260 nanometers. They offer quick response and good sensitivity at comparatively short ranges, roughly 0 to 50 feet. Because they are susceptible to arc welding, halogen lamps, and electrical discharges like lightning, they tend to be sited for indoor applications. Thick, sooty smoke can also cause failures due to blocking the UV radiation. When a UV optical sensor is integrated with an IR sensor, a dual band detector is created that is sensitive to the UV and IR radiation emitted by a flame. The combined UVIR flame detector offers increased immunity over the UV detector. It operates at moderate speeds of response and is suited for both indoor and outdoor use. As with UV detectors, however, the detection range of these instruments may be reduced by heavy smoke. MultiSpectrum infrared flame detectors use multiple infrared spectral regions to further improve differentiation of flame sources from non-flame background radiation. These flame detectors are well suited to locations where combustion sources produce smoky fires. They operate at moderate speeds with a range of up to 200 plus feet from the flame source, both indoors and outdoor applications. These instruments exhibit relatively high immunity to infrared radiation produced by arc welding, lightning, sunlight, and other hot objects that may be encountered in the industrial background. Visual flame detectors employ charged coupled devices, CCD image sensors, and flame detection algorithms to establish the presence of a fire. The imaging algorithms process the live video image from the CCD array and analyze the shape and progression to discriminate between flame and non-flame sources. Unlike IR or UV flame detectors, CCTV visual flame detectors do not depend on emissions from carbon dioxide, water, and other products of combustion to detect fires, nor are they influenced by the fire's radiant intensity. Despite their advantages, visual flame detectors cannot detect flames that are invisible to the naked eye, such as hydrogen flames. Heavy smoke also impairs the detector's capacity to detect a fire, since visible radiation from the fire is one of the technology's fundamental parameters. Optical flame sensing technologies may be selected to suit the requirement of flame monitoring applications, including detection range, field of view, response times, and particular immunity against certain false alarm sources. Here is a breakdown of the flame response sensitivities. Flame detectors have varying degrees of flame response sensitivity according to their type. So these are the maximum detection distances in feet and meters. For UV flame detectors, you're looking for a gasoline fire of about 15 feet. Infrared single IR is, 50 feet. Infrared is 50 feet. UVIR, roughly 50 feet. And then you'll notice for IR3 and multi-IR, there's a large increase in the detection range up to 215 feet. And actually, we have one now that just came out not too long ago that can go to 300 feet. If you notice the different detection ranges for the different types of fuels, gasoline is the industry standard for all our detection ranges. So when we say we can see gasoline at 215 feet, that's at our maximum sensitivity. For example, methane gives off roughly 60 to 70% of the energy that gasoline gives off, which is why at the same sensitivity levels, it can only be detected at 100 feet. This also works for fuels such as diesel and jet fuel, which are also 70% of the energy that gasoline gives off. So when you see the detection ranges, that doesn't mean necessarily for all types of fuel. That's just gasoline, and then based on the other types of fuels, their index, you can determine the type of detection ranges. So now we'll kind of go over the Spectrex Flame Detector portfolio. MultiSpectrum infrared flame detectors use multiple infrared spectral regions to further improve differentiation of flame sources from non-flammable background radiation. The four sensors sample unique IR spectral wavelengths and convert those signals into a digital format to extract time and frequency data. Four sensors provide more data, excellent immunity to false alarms, increased detection distances, superior reliability, and better performance under various environmental conditions. However, because multispectrum infrared flame detectors are the most technology advanced, they do come with a price premium. The Spectrex 4040M multispectrum infrared hydrogen flame detector is specifically designed for the detection of hydrocarbons and hydrogen flames. Two of the four infrared sensors are used to sense the hot carbon dioxide generated as a product of combustion. The 4.3 micron wavelength is the known peak for hot carbon dioxide. The other two sensors are sensing the hot water vapor generated from the combustion of hydrogen, ammonia, and metal oxides, silane, and other non-organic fuels. The emission of hot water vapor produces a strong peak at 2.7 microns. The 4040M detects hard-to-see hydrogen flames and other non-carbon-based materials without the false alarm associated with traditional technologies. Next, we have the Spectrex 4040i multispectrum infrared flame detector. It's based on accurately analyzing the multispectral signals by utilizing four separate IR sensors. The four sensors are used to detect hot carbon dioxide, which has a relatively strong and well-defined peak at wavelengths around 4.3 microns. The 4040i detects fuel and gas fires at long distances. For example, this product will detect a 1 square foot gasoline pan fire at 215 feet in less than 5 seconds. The 4040i also provides the highest immunity to false alarm and enhanced overall coverage range. We also have a version of this that is called the 4040 UFI, which is the Ultrafast IR3. It has the ability to detect a flash fire at 50 milliseconds and has an increased detection range of up to 300 feet. Ultraviolet infrared flame detectors. When a UV optical sensor is integrated with an IR sensor, a dual band detector is created that is sensitive to the UV and IR radiation emitted by a flame. The combined UV-IR flame detector offers increased immunity over the UV detector, operates at a moderate speeds of response, and is suited for both indoor and outdoor use. As with the UV detectors, however, the detection range of these instruments may be reduced by heavy smoke. In effect, these instruments combine both IR and UV detectors in a single housing. Both detectors are required to detect simultaneous radiation before generating an alarm, therefore ensuring the good immunity to false alarms. The Spectrex 4040 UFL Ultrafast Ultraviolet Infrared Flame Detector was specifically designed to meet two major requirements: high speed response of 20 milliseconds and high reliability for immunity to false alarms. The 4040 UFL detects hydrocarbon-based fuel and gas fires, hydroxyl and hydrogen fires, as well as metal and inorganic fires. This UVIR flame detector senses radiant energy in the shortwave section of both the ultraviolet and infrared portions of the electromagnetic spectrum. The signals from both sensors are analyzed for frequency, intensity, and duration. Simultaneously, detection of radiant energy is in both the UV and IR sensors triggers an alarm signal. In addition, the UV sensor incorporates a special logic circuit that helps prevent false alarms caused by solar radiation. The 4040L4B provides a combination of UV and IR sensors, where the IR sensor operates at a wavelength of 4.5 microns and can detect hydrocarbon-based fuels and gas fires. Like the 4040 UFL, the 4040L4B signals from both sensors are analyzed for frequency, intensity, and duration. Simultaneous detection of radiant energy in both the UV and IR sensors triggers an alarm signal. In addition, the UV sensor incorporates a special logic circuit that helps prevent false alarms caused by solar radiation. Process and plant engineers in the oil and gas industry and a wide range of other hazardous process and manufacturing industries require continuous flame monitoring equipment to prevent catastrophic fires. Technologies may be selected to suit the requirements of flame monitoring applications, including detection range, field of view, response time, and immunity against false alarm sources. The Spectrex 4040 flame portfolio incorporates both MultiSpectrum infrared and ultraviolet infrared technologies. Our flame detectors lead the industry with top performance specifications and were designed to meet all customer needs. Not showing on this slide are the 4040 UFI, as I mentioned earlier, and the 4040 UB, which is a ultraviolet only flame detector. Ultraviolet only is used for indoor applications only, as it's susceptible to false alarms. We use it specifically for applications that are enclosed rooms. We do a lot for diesel generators that are enclosed. And then we also have the Spectrex 4040 LB, which is a non-ultrafast version of the UFL that can detect hydrocarbon fires and hydrogen fires. So a couple features for the Spectrex portfolio, the 4040 series. We have a manual and automatic testing of optical surfaces. There's a built-in test which allows it to have SIL2 located at the top of the detector, at the top of the lens. If you notice in this picture, at the top there is a reflector that is hanging down over the lens. What this does is the built-in test sends a signal through a bulb that's just behind that reflector, sends it out through the lens to the reflector that bounces it back into the detector. And this does two things. First, it checks the sensors internally to make sure everything is operating correctly. And second, it makes sure that the lens is clean so that there's no reduction in signal and no effect to response time. If for any reason the built-in test fails, the detector will go into fault, which will allow you to be notified to come check the detector, check the lens, make sure everything is good. This happens at startup. The built-in test runs at startup and every 15 minutes after startup. And once, if the detector is in built-in test fault, it can still detect a fire. A good way to test this is if you were to take a business card and put it underneath the reflector and do the startup process. The detector will go through its normal startup and run a built-in test. The built-in test will fail and the detector will go into fault mode. You can then test the detector with either a live fire or a flame simulator. The detector will still go into alarm. When the business card is removed, the detector after 15 minutes will run another self-diagnostic built-in test, and seeing that the lens has been cleared, it will go back into normal operation. We have a heated window for operation in harsh weather conditions for snow, ice, condensation. This is set at 15 degrees Celsius, and you can make alterations to the when the heated window begins through the software of the detector. The operating temperature range is -55 degrees Celsius to +85 degrees Celsius. or negative 67 degrees Fahrenheit to 185 degrees Fahrenheit. We have the tricolor LED, which provides external status indication. We have multiple outputs. We have relays with options for alarm, fault, and auxiliary based on the wiring configuration that you choose. We have 4 to 20, HART, RS485, and for our 2 Ultrafast models, we have analog. The flame detector specifications. Each detector has the spectral responses listed. 4040I has 3 IR bands. The 4040M has multi-IR bands, which are the 2 in the carbon wavelength and the hot H2O wavelength spectrum. The UFL has UV and IR. The L4B also has UV and IR. Our response times are typically between 5 seconds, depending on the technology. The UVIRs are typically at 3 seconds with a flash fire response time of 20 milliseconds for the 4040 UFL. For the field of view, the 4040I, UFL, and L4B all have a horizontal cone of vision of 100 degrees and a vertical cone of vision of 95 degrees. The 4040M has a special lens on it that reduces the field of view because we are looking for the also for the non-hydrocarbon fires. For gasoline, the field of view is 67 degrees horizontal and 70 degrees vertical. And for hydrogen is 80 degrees for both horizontal and vertical. Our warranty for the 4040 series are 5 years. We have low power consumption of 130 milliamps for alarm and 90 milliamps for standby. We have enclosure materials of stainless steel and aluminum based on the certifications that you choose. And here listed are the weights. For stainless steel, it's approximately 6.1 pounds. For aluminum, it's 2.8 pounds, and our tilt mount is 2.2 pounds. Real quick, I do also want to mention the light industrial and commercial options, which are called the 2020M series. These are the mini series. Our Spectrex 2020MI MultiSpectrum infrared flame detector uses the same type of sensors used in the 4040I. Our 2020ML is an ultraviolet infrared hydrogen flame detector. Both the MI and the ML come with a stainless steel housing. For commercial applications, we have the 2020 MPI, which is a multi-infrared flame detector using the same type of sensors as the other IR3s. This one comes in an ABS plastic weather cover, ABS plastic housing, and comes automatically with a tilt mount and a weather cover. It comes with 2 options for outputs, one for relays or one for 4 to 20. Here are some of the flame detector specifications. All 3 have response times typically of 5 seconds. They all have the same field of view, 100 degrees horizontal and 100 degrees vertical. Temperature range is between negative 40 degrees Fahrenheit to 160 degrees Fahrenheit. These 3 have a 3-year warranty. The enclosures, again, for the MI and ML are stainless steel, and the MPI is polycarbonate, ABS plastic. And the weights are 2.5 pounds for the MI and the ML, and 10.6 ounces for the MPI. Installation considerations. Flame detector installation design criteria. So when you're looking at the application, we want to look at the dimensions of the space, any potential blind spots or obstructions, and the source of radiation. Other criteria is the speed of detection, redundancy or voting, and the flame distance. Unpacking the product, the 4040 series flame detectors automatically come with a plastic weather cover and the manual. When you first power up the detector, you can use a handheld communicator to connect with it. All you need is 24 volts, 250 ohm resistor, milliamp meter, the connection to the transmitter terminal block, and a configuration tool, either HART handheld or Trex, and you can go into it and do some of the configurations. Using the guided setup to configure the detector, users will step through an intuitive method that includes all of the tasks required to perform the basic setup of the device. These tasks include setting tagging and devicing information, configuration of the built-in test, sensitivity configuration, and setup of the window heater. I should mention, because I forgot it earlier, the 4040i and the 4040M IR3 and multi-IR flame detectors have 4 sensitivity ranges. And so with going into the detector using the software or either making the selection when they're first ordered, you can set the sensitivities to 50 feet, 100 feet, 150 feet, and 215 feet. So the first configuration step is to set the device short and long tag. Some users don't set a device tag, so this step is optional. Second, the method will allow a message and descriptor to be set. The method then transitions to configuration of the built-in test. I previously discussed the built-in test is used to confirm window cleanliness and monitoring how the sensors are reacting. Because this is a safety device, enabling the feature is strongly recommended. Next, the detector sensitivity can be configured. 2 of the 4 flame detectors offer the flexibility to configure the detection range. These are the 4040i and the 4040M. Please note that the default range of the 4040i and 4040M is set at 100 feet. If longer detection range is required, this will need to be configured either by the end user using the RS-45 software or at the factory when it is ordered. Last, the method walks through the setup of the window heater. The window heater is used to increase the temperature of the optical surface to improve performance in icing, condensation, and snow conditions. Spectrex strongly recommends setting the window heater on continuously or on per temperature change to ensure the detector lens is clear. The 4040 flame detectors are designed to operate as standalone units directly connected to an alarm system or an automatic fire extinguishing system. The detector can also be a part of a more complex system where many detectors and other devices are integrated through a common control unit. Depending on the application, alarm setup may also be required. Using the HART communicator, alarm delay, latching, and activation can be configured. First, the detector is equipped with alarm delay option, which provides for programmable time delays. These delays can be enabled to help improve the false alarm immunity of the device. When enabled, the detector delays the execution of the alarm outputs by a specified period of time, allowing the detector to evaluate the condition for a longer period of time. The alarm delay option affects the output relays and the 4 to 20 signal. The LEDs and output indicate warning levels during the delay time only if the fire condition exists. Next, the alarms can be configured to latching or non-latching. If enabled, the alarm outputs remain latched on the following detection of a fire that has already been extinguished. Lastly, the alarm activation is configured. The configuration can be enabled or disabled. By default, the device is set up so that a successful manual built-in test activates the alarm relay for approximately 3 seconds. Upon completion of the guided setup and alarm setup, the basic configuration of the detector is complete. All right, field installation. Installation best practices. Once the device has been configured on the benchtop, it is ready to be installed on the field. The flame detectors act as the eyes of the plant, meaning that they will be installed in high locations where it is likely to have clear line of sight. Most flame detectors are placed in the corner of the structure or fire zone to achieve maximum coverage along both walls and into the area. Detectors should be positioned at 45 degrees downward and roughly 1.5 feet from the ceiling. So in this mapping software that we have on the screen, you have to remember that the flame detectors, in a sense, work like your eyes when they're trying to detect an area. They cannot see through can't see through walls, can't see through different types of tanks, etc. So when you're looking at them, when you're installing them, you want to have them faced 45 degrees down and looking at the most likely place that the ignition of the fire will start. The detection range. Detection and sensitivity and detection range are related to the size of a fire and fuel type. Detection range can be affected by the desensitizing effect of sunlight, water, fog, steam, and black body radiation. Detection range and field of view define area coverage per device. And here's a list of the detection, the percent of the detection as sensitivity range, and our maximum distances for each different type of fuel. Also at the bottom right are the field of view for the flame detectors. This is showing the 100-degree horizontal field of view. As mentioned before, different types of gases give off a different index. So when you're looking at the field of view, this is set to maximum sensitivity for gasoline. If you were to look at a diesel fuel, that would come to about 70%, and that would give you an idea of what your detection range would be. One must keep in mind that the sensitivity to a fire is not constant over the entire extent of the cone of vision. The detection range is reduced when it moves away from the optical axis, and there is even a very rapid fall on the edge of the cone. Generally, vision angles are given for half distance sensitivity limit versus the one obtained on the optical axis. It is therefore appropriate to take this value into account in the definition of the installation. So this is to show the principles of the flame detection inverse square law. As mentioned earlier, when the size of a fire increases by 4, the detection range can increase by 25%. It is also important to consider the environmental conditions of the protected area. In most cases, false alarms are not caused by a fault in the detector, but rather by its natural response to radiation sources and other interferences to which it is subjected. Such interferences may be natural, example, sunlight, rain, and lightning, or man-made, example, that would be artificial lighting and radiation from heaters. The detectors are designed to discriminate between nuisance alarm sources and real flames. Other environmental conditions to consider are inhibitors. These substances or vapors are known to blind the detector and inhibit its ability to detect fires. Common inhibitors include smoke, dust, dirt, oil, grease, silicone cleaners, window glass, water, ice, snow, and steam. These inhibitors are known to absorb the energy from the flame, prohibiting the radiated energy to reach the detector. The first step is the physical installation of the device in the field. This includes 2 distinct steps. The first is to physically mount the device in the field, and the second is to verify the detection coverage. We will begin by discussing mounting accessories used for installation. Flame detectors are mounted remote from the process, and depending on the application, the mounting requirements may differ. To meet this need, the 4040 flame detectors can be used with a number of mounting accessories. The tilt mount provides accurate directional selection to optimize area coverage for the flame detectors. This accessory enables the detector to be rotated up to 60 degrees in all directions. 1 tilt mount is required for each flame detector. It should be noted that the 4040 cannot be mounted without the tilt mount. The second accessory is the pipe mount, which allows the 4040 to be mounted to a pipe. To successfully mount the flame detector, both a tilt mount and a pipe mount are needed. The third accessory is the air shield. Optical flame detectors are often used in highly polluted or dirty areas that force maintenance personnel to access the detector frequently to clean its optical lens. The air shield allows their installation under tough environmental conditions where they may be exposed to oil vapors, sand, dust, and other particulate matter. This is a really great accessory for applications such as paint booths. Fourth, the duct mount allows flame detection in areas where high temperatures exist or in cases where the detector cannot be installed inside the area. It comprises a special duct mount arrangement with specific optical window to allow installation in high temperature duct applications. Last, the weather cover protects the detector from different weather conditions, such as snow and rain. A plastic weather cover is included with each of the flame detector. If a stainless steel weather cover is needed, an additional accessory must be ordered. Only standard tools are needed to install a Spectrex Flame Detector. They include a 3/16 inch hex key, a 1/4 inch hex key, and an extraction key, a 6mm flat screwdriver, and a 2.5mm flat screwdriver. 2 hex keys and extraction keys are included with the flame detector. The accessory that is most commonly used with the Spectrex 4040 flame detectors is the tilt mount. Optical flame detectors are based on line-of-sight detection of radiation, meaning the detector must be positioned to see the flame. Once the detector location has been identified, the tilt mount is used to position the face of the optical detector. By using the horizontal and vertical locking screws, the detector can be rotated 6 degrees in all directions. It is critical that one tilt mount is purchased with each flame detector. With the transmitter mounted, the next step is wiring the transmitter. Wiring is fairly straightforward. Connect the positive power lead to the terminal marked with the 1, and the negative power lead to the terminal marked with 2. As a reference, the table describes the function of each terminal for all output configurations. Use shielded twisted pair wiring between 24 gauge and 14 gauge. Wire length should not exceed 5,000 feet. And remember, as previously discussed, you must have at least 250 ohms of resistance connected in the series for HART communication. This resistance is typically provided by the control system analog input card. This also lists the different wiring configurations for the flame detectors. If you notice, option 1 includes normally open alarm, normally closed fault. Option 2 includes both normally open and normally closed alarm and normally closed fault. Option 3 includes normally open and normally closed alarm and normally open fault. And then options 4 and 5 are different variations with the fault, and also includes an auxiliary relay. The detector incorporates several types of outputs suitable to the different control systems, 4 to 20 stepped with HART, relays, and RS-45. Depending on the output configuration selected when ordering, different outputs will be available. This shows a better representation of the different types of wiring configurations. Once the detector is configured and installed, it is important to test the operational readiness of the entire fire detection system. To test the detector under real-life fire conditions without using the associated risk of an open flame, a flame simulator should be used. By simulating a fire that actually triggers the detector outputs, the Spectrex Flame simulators perform an essential end-to-end loop test and verify window cleanliness. When verifying the detector wiring and configuration, it is helpful to understand the detector's output signals. A 3-color LED is positioned on the face of the detector to provide visual indication of the status of the device. When the flame simulator is used to perform an end-to-end loop test, the color of the LED will turn red, indicating the device has gone into alarm. Once the device has successfully been verified and tested, it is ready for use. Flame detection maintenance. The flame simulators are used to simulate a real fire condition and test end-to-end functionality. Depending on the flame simulator, it emits either infrared or UVIR radiation in a unique sequential pattern corresponding to and recognizable by the detector as a fire. This allows the detector to be tested under simulated fire conditions without the associated risk of an open flame. Testing typically is conducted every 6 months per standards. Again, the flame detector accessories, the tilt mount connects directly to the flame detector. We also have a pole mount that's available in either 2 inch or 3 inches. This is used in conjunction with the tilt mount to mount the detector on a pole. We also have a duct mount, air shield, RS-45 software, and the optional stainless steel weather cover. The flame simulators come automatically with the lithium battery, and available we sell spare batteries and the chargers. We also have a RS-45 harness kit that you can use to connect to the flame detector to make any kind of changes internally. The Software to do this is free on our website at spectrex.net, but you will need the RS-45 harness kit to connect to it. There are several types of flame simulators that we use. The 4040i has a specific one, which is the FS1100, that is for IR3. The FS1200 is for the UVIR detectors, as it emits UV and IR wavelengths. And then the FS1400 is used for the 4040M for the MultiSpectrum. And again, the reason for this is because the sensors are located in the hot CO2 position and the hot H2O position of the wavelengths of a fire. The FS1100 will also work with the 2020 MI and the 2020 MPI as they are IR3, and the FS1200 will also work with the 2020 ML. And with that, that will conclude our presentation. I want to thank everyone for listening, and if you have any questions again, you can send it to info, I-N-F-O, @protectowire.com. Thank you.
Well, that concludes today's webinar. A big thank you to Ty Allen from Spectrex for all the informative presentation and to everyone who's attended. A link to this recording is going to be emailed out shortly. And just as a quick reminder, in case you didn't make it into the Q&A chat in the bottom left, please email any questions you have to info, I-N-F-O, @protectowire.com. Thanks, everyone. Goodbye.